Welcome to Technical Analysis in Excel, Part 1, Dynamic Charting, Data-Driven Visualization. This course is built around one central idea. Your Excel charts should update themselves. Every time you paste in new market data, every time a new trading day closes, your charts should extend automatically with no manual intervention. In Part 1, we focus on the foundation. We will cover how charts actually work in Excel, why the default setup breaks down for live market data, and how a single formula change fixes it permanently. To follow along, open the example file, part1_dynamic_charting_examples.xlsx. It contains 650 rows of daily price data and working versions of every formula covered in this course. You can replace the sample data with your own at any time, and all charts will update automatically. By the end of this part, you will have a chart that always reads the very last row of your data, whether that data has 100 rows today or 10,000 rows a year from now. Let's start from the beginning. Before we fix anything, we need to understand what a chart actually is in Excel, because most people have the wrong mental model. A chart in Excel is not a picture of your data. It is a live formula connected to your data. Every chart has three structural elements. First, the data series. This is the set of values plotted as a line, bar, or area on the chart. In a stock price chart, this is your closing price column. A single chart can hold multiple series at once, for example, overlaying a price line and a 20-day moving average on the same axis. Second, the axis. There are two reference lines that define the chart's coordinate space. The x-axis runs horizontally and holds your categories, which for a time series chart means dates in column A. The y-axis runs vertically and holds your numeric values, which means price levels in column B. Excel scales both axes automatically, but you can override the bounds if needed. Third, the difference between chart area and plot area. These two are frequently confused. The chart area is the entire outer frame, including the title, legend, and all surrounding white space. The plot area is only the inner grid where the data lines are actually drawn. You can resize and format them independently. Now, what holds all three elements together is a hidden formula called series. Click on any line inside an Excel chart and look at the formula bar. You will see the series function with arguments for the series name, the x-axis range in column A, and the y-axis range in column B. This is the key insight. A chart is a live reference, not a snapshot. Change a value in your data table, and the chart updates immediately. Delete the source rows, and the chart breaks. Copy the chart to another sheet, and it still reads the original data. In the example file, go to the raw data sheet. Column A holds dates, column B holds closing prices. Every other sheet in this workbook pulls directly from these two columns. This two-column structure is all you need to follow every example in this course. Now here is the problem, and it is one that catches almost everyone who uses Excel for market data. When you create a chart by selecting, say, columns A and B down to row 100, Excel writes the endpoint literally into the series formula. The formula becomes series blank sheet 1A2 to A100, sheet 1B2 to B100, 1. That B100 is now fixed. It is hard-coded. Add price data in rows 101, 102, 103, and the chart ignores all of it. The range is locked at row 100 until you manually go in and change that number. Think about what this means in practice. You build a price chart in January with 20 rows of closing prices in column B. By June, you have 120 rows. The chart still shows only the original 20. Every morning you paste in yesterday's close. Every morning the chart does not update. To fix it manually each time, you must click the chart, right-click the series, choose Edit Series, change B21 to B121, and then repeat the same process for the date axis in column A. Then do it again tomorrow and the day after. Multiply this across every chart in your dashboard, every trading day, over months. One missed update produces a chart that silently shows stale data, and that is the worst kind of error because it looks correct. There are two ways to escape this trap. Option A is to convert your data to an Excel table using Ctrl+T. The chart range expands automatically when you add rows. It is fast and simple, but it breaks down when your data spans multiple sheets, when you use named ranges, or when you are building a multi-layer dashboard with separate sheets for raw data, indicators, and charts. Option B is the approach we use throughout this course. Replace the hard-coded B100 with an index formula that always calculates the row number of the last entry. When new data arrives, the range extends automatically. This approach works at any scale, across any number of sheets, with no limitations. In the example file, open the sheet called One Static versus Dynamic. The left side shows a chart frozen at row 102. The right side uses the dynamic formula and reads all 650 rows. Add a row to raw data, and only the right chart responds. What you are watching is a 30-second demonstration of the exact problem and solution we just described. Both charts start with the same 60 data points from column B. At this stage, they look completely identical because they are reading the same data. Then 20 new rows of data arrive. Watch the left chart. The line stops at row 60. The new data exists in the spreadsheet, and you can see it drawn as a faint dotted line, but the chart completely ignores it. The series formula has a hard-coded endpoint, and it will not move no matter how much data accumulates. Now watch the right chart. The line extends automatically to row 80. No formula editing. No right-click menu. No manual steps at all. The dynamic range detected the new data in column B and included it immediately. The difference between these two charts is a single change inside the series formula, replacing a fixed cell reference like B60 with an index function that calculates the last row automatically. The next slides show you exactly how to build that formula. Now let us build a chart from scratch and walk through every step. Step 1. Structure your data as a flat table. Before inserting anything, your data must be a clean flat table with one row per observation and one column per variable. No merged cells, no blank rows, no subtotals embedded in the middle of the data. For a price chart, the minimum is 2 columns. Column A holds dates, which must be proper Excel date values and not text strings. If dates are stored as text, the x-axis will not sort correctly, and the match formulas we use later will fail silently. Column B holds the closing price as a plain number, with no currency symbols or embedded commas. This is exactly the layout in the raw data sheet of the example file. Open it now and study the structure before building your own. Step 2. Select and insert. Select both columns A and B, including the header row. Go to Insert, then Charts, then Line. Excel reads column A as x-axis categories and column B as the y-axis data series. The chart appears immediately. Step 3. Verify the series formula. Click on the line inside your new chart and look at the formula bar. You will see the series function with the hard-coded endpoints. For example, A2 to A100 for dates and B2 to B100 for prices. These are exactly what we replace in the next 2 slides. Step 4. Understand what you have built. This chart can update existing values instantly and display multiple series at once. What it cannot do yet is automatically include new data rows. It will always read exactly the rows selected at creation time. Nothing more, ever, until we apply the dynamic formula. A few good habits worth building right now. Freeze the header row so column labels stay visible as you scroll. Verify that your dates display as dates and not as 5-digit serial numbers. And keep column A as dates and column B as prices consistently across every sheet in your workbook. The example file follows this structure throughout. Every formula, every chart, and every cross-sheet reference in this course assumes column A for dates and column B for prices. There are 3 ways to create a dynamic chart range in Excel, and they are not equal. This table compares them directly so you can make the right choice from the start. Method 1. Offset plus counta. The offset function constructs a range starting at a fixed cell and extending as far down as counta calculates. The formula works, but offset is a volatile function. That means it recalculates every single time anything anywhere in the workbook changes. Every keystroke, every paste, every cell edit triggers a full workbook recalculation from scratch. In a technical analysis dashboard with hundreds of EMA, MACD, RSI, and Bollinger Band formulas referencing columns A and B across multiple sheets, even a single offset-based chart range can freeze the file for several seconds on every update. Avoid it for any production dashboard. Method 2. Indirect. Indirect is worse. It is also volatile, and in fact it is the most volatile of the 3 methods. On top of that, it has an additional problem. It stores the sheet name as a plain text string inside the formula. If you ever rename a sheet, Indirect breaks silently without showing any error. There is no warning, no red cell, nothing. The data just disappears from the chart. And because Indirect resolves at runtime, Excel's formula auditing tools cannot trace its precedents, making it essentially impossible to debug in a complex workbook. Avoid Indirect entirely. Method 3. Index match. Index is fundamentally different. Index is not volatile. It recalculates only when its direct precedents change, meaning one data update in column B triggers one targeted calculation, not a full workbook sweep. It is fully auditable, it survives sheet renames, and it scales to dashboards of any size and complexity. In the example file, the formula reference sheet lists all 3 method formulas side by side with the index version highlighted. You can copy directly from that sheet into your chart series formula. The conclusion is clear. For any dashboard reading from column B with dates in column A, always use index. Let us now build the complete dynamic range formula step by step. With dates in column A and closing prices in column B, the full formula looks like this. Sheet $1 B $2, colon, index, open parenthesis, sheet $1 B colon B, comma, counta, open parenthesis, sheet $1 A colon A, close parenthesis, close parenthesis. There are 3 parts to understand. Part 1. Counta of column A. This counts every non-empty cell in column A, which is your date column. With 500 trading days of data plus a header row, counta returns 501. That is the row number of the last data entry. We count column A rather than column B because the date column is always fully populated, even if some price cells in column B happen to be blank on certain days. Using column A as the counter makes the formula more reliable. Part 2. Index of column B with that count. This looks up the row number returned by counta inside column B and returns a cell reference, not the stored value, but the actual cell address. Sheet 1B501. Index is one of the very few Excel functions that can return a reference rather than a value. That property is exactly what makes it work as the right-hand boundary of a range expression. Part 3. B2 colon index. The colon between a fixed starting cell and the index result constructs a dynamic range. The start, which is B2, is fixed at your first data row and never changes. The end, which is the index result, moves automatically as new rows are added. Add 50 new rows to column B, and the range extends to cover all of them immediately. The complete series formula using this technique is series blank a 2 colon index of a colon A counta of a colon A, B2 colon index of B colon B counta of a colon A, 1. Both the x-axis date range in column A and the y-axis price range in column B are now fully dynamic. Paste 100 new rows and both ranges extend to cover them immediately. No formula editing, no broken references, no manual work, ever. In the example file, go to the one static versus dynamic sheet. The right-hand chart uses exactly this formula structure. Add one row to raw data and watch only the right chart extend. To apply this to your own chart, click the chart line. Go to the formula bar, find the hard-coded endpoint like B100, and replace it with index of B colon B, counta of a colon A. Do the same for the date range in column A. Add one test row. If the chart extends to include it, the dynamic reference is working correctly. Then apply the same change to every chart in your dashboard. Everything we have built so far always shows the full available data, extending to the very latest row. But in practice, you often need something more specific, a 20-day momentum chart, a year-to-date performance view, or a chart anchored to a specific event date like an earnings release. This slide shows you how to build all of them using the same index logic. The core principle is called the two-endpoint principle. Every series range has exactly two boundary formulas, a start and an END. The END is always the same expression in every formula on this table. Index of data, counta of data. That always points to the very last row of column B. The start is your variable. Change how you define the start, and you change what time period the chart covers. There are two ways to define the start. Rolling windows use arithmetic. Subtract n-1 from counta to shift the start exactly n rows back from the most recent entry. For the last 5 trading days, subtract 4. For the last 20 trading days, subtract 19. For the last 252 trading days, which is approximately 1 year of trading data, subtract 251. Change the n value and the entire window shifts instantly with no formula editing in the chart itself. Event-driven anchors use the match function with a date formula. Instead of counting backward from the end, you pin the start to a specific calendar date. For year-to-date, the start formula uses match with date of year-to-date, 1, which finds the row position of January 1st in column A. As new closing prices arrive each day in column B, the END keeps expanding while the start stays locked on January 1st. The same logic gives you month-to-date, quarter-to-date, or any custom event date stored in a settings cell. For the fixed historical window at the bottom of the table, both endpoints use match, so the chart always shows exactly the same historical period regardless of how much new data arrives. In the example file, the two rolling windows sheet has working formula extraction blocks for the 5, 20, 60, and 252-day windows. The 3 event-driven sheet does the same for month-to-date, quarter-to-date, year-to-date, a custom start date, and a fixed historical window. The formula reference sheet lists all 10 formulas in copy-paste ready format. One important note, in all these formulas, data refers to your price column, which is column B, for example sheet $1 B colon B. Date_call refers to your date column. which is column A. For example, sheet $1A:A. Always use column-locked references with the dollar signs so the formulas survive copy-paste across worksheets. This animation demonstrates the three core concepts from the formula matrix, applied to 650 rows of real price data. Section 1 shows rolling windows. The highlighted portion of the chart represents the active data window, always anchored to the rightmost, most recent point. Watch as the window shrinks from 252 trading days, which covers approximately 1 year, down to 60 days for a quarterly view, then to 20 days for a monthly view, and finally, to just 5 days for a weekly snapshot. In every case, the right endpoint stays fixed at the latest row. Only the left endpoint moves. Section 2 shows event-driven anchors. Here the anchor is a specific calendar date pinned in column A using the match function. As we move from year to date, to quarter to date, to month to date, the anchor point moves rightward and the highlighted region shrinks. Each anchor is fixed in time, while the right endpoint continues to expand automatically as new data arrives each day. Section 3 shows auto expansion side by side. Both charts start with the same 620 rows of data. Then 30 new rows are added one at a time. The static chart on the left freezes immediately. The new data exists in the spreadsheet, but the chart ignores it completely. The dynamic chart on the right extends automatically with every new row, no intervention required. This is exactly why the dynamic index formula is the only correct choice for any live market data dashboard. That completes part 1. You now have the complete foundation, charts that never need manual range updates. In part 2, we build MACD, RSI, and Bollinger Bands directly on top of this infrastructure, all in pure Excel formulas.